Welcome to Hartman Math. This is lesson 7.4, partial fractions, where we're going to do partial fraction decomposition, an important calculus skill, where we're taking a fraction, a rational expression that has a denominator that's not linear, and we're going to break it up into the sum of fractions that have linear denominators. So example number 1, we want to be able to break this down and have this be the sum of fractions that have linear denominators. So step number 1 is going to be to factor your denominator. And then step number 2, we're going to go ahead and split it up. At this point, the numerators, when we split it up with this as a denominator and this as a denominator, are unknown. So we'll use variables like a and b for that. So a over x minus 5 plus b over x plus 2. It really doesn't matter if you had this switched. It's not a problem. It just means that your a and b are going to end up being switched, but you'll get the same answer at the end. So the next thing to do is to add these two together. We know that the denominator is going to end up being this, our LCD, but the numerator, remember, we need to create that common denominator by multiplying this fraction top and bottom by x plus 2, this one by x minus 5. So there we go. We're going to see really for our solving for a and b, we're going to be very focused on the numerator. That this has to equal the x plus 16. And that's what's going to generate our equation. And we can go ahead and simplify this by distributing your a and your b, and then regrouping this in terms of your x's and your constants. So we got ax plus bx means that we have a plus b times x. And then as a constant, we have 2a and negative 5b as a constant. We don't really need to write this all out. We could have just written this and have that equal to x plus 16. Numerator equals numerator. And then the system becomes based on the coefficients. The coefficient of x here needs to equal the coefficient of x here. A plus b has to equal the 1 here. The constant, 2a minus 5b, has to equal the 16. So there's our x equation for our coefficients, and there's our constant equation. We now have a system of equations, and we're going to solve that. I would probably lean towards the elimination method. So I'm going to multiply the top equation by 5 and add those together. So we get 7a is equal to 21. Clearly that means that a is 3. And if a is 3, then b is going to have to be negative 2. So our final answer, we're going to go back to here, replace with 3, replace with negative 2. There's our answer. It's also acceptable to write plus negative 2 here. And we decomposed the fraction. The reason that we do this is that doing calculus on this is going to be a lot easier than on this. All right, example number 2. In example number 1, our two factors for the denominator were distinct. They were different. Let's see what happens here when we get repeated linear factors. So same process. We're going to go ahead and factor our denominator. So I think we could factor out a greatest common factor and then factor the trinomial from there. And you're going to notice that after we factor out the x, we're going to get x plus 1 times x plus 1. We want to write that as x plus 1 squared. And there is our repeated linear factor. X plus 1 as a factor was repeated. There's two factors of x plus 1. So when we go ahead and do this, here's how we're going to break it apart. If it had just been x times x plus 1, we would split this up into two fractions, one with the denominator of x and one with the denominator of x plus 1. When we have a repeated, we're going to need the x. We're going to need the single x plus 1, and then we're also going to need an x plus 1 squared. So those now we've got 3 fractions as we break it up, so 3 unknown numerators. So clearly with 3 unknown numerators, we're going to need 3 equations for that. All right, so again, we're going to go ahead and add these together. Now remember, I'm probably not going to have the entire fraction, as the system is going to be generated just by the numerator. So I know that this one, for our LCD right here, this one's missing x plus 1 squared. I'm going to multiply top and bottom by x plus 1 squared. This one's missing an x and another x plus 1. That's what I'm going to multiply top and bottom. This one's just missing an x. So that would be my numerator by multiplying all these by the missing factors, creating that common denominator. And we know that that numerator is going to have to equal this numerator over here. So now I'm going to do some work as far as simplifying this. I'm going to have to square the x plus 1. Over here I need to multiply the x and the x plus 1. And now I think I can generate my system of equations. I'm going to have an x squared equation based on the coefficients. Something is going to equal 7. So all the things that have x squareds. So an ax squared, a bx squared, and that's it. So a plus b is going to have to equal 7. Now I'm going to have to get an x equation. Something is going to equal 6. So where am I getting all the x's? A times 2, so 2ax. So 2a plus b plus c, those are all the x's. 2a plus b plus c is going to equal the 6. And now I need a constant equation. Where am I getting constants? A times 1. No constants here, no constants here. So that one's a pretty easy equation. 1a, or just a, is going to equal 2. And that's going to definitely help solve our system, because we already know that a is 2. So then I can replace here, do my back substitution. 2 plus b is 7. So that's going to mean b is 5. And then we can replace with 2 and 5 to find the c. And we're going to get c is negative 3. So a is 2, b is 5, c is negative 3. We can write it this way, or I could put plus negative 3. It works out the same either way. That's it for today. I'll see you next time.